Hey class, this is lesson 6.4, Applications in Linear Systems. Our objective here is to choose the best method for solving a system of linear equations. That means should we use the graphing method, where we make a graph of the equations, or should we use substitution, or should we use elimination? All right, go ahead and pause here and see if you can answer these questions. All right, so here's a concept summary, just to give you an idea. Graphing should be used when you want a visual display or when you want to estimate a solution. You don't really need to be that accurate. Substitution should be used when one equation is already solved for one of the variables or when it is easy to solve for one of the variables. Elimination should be used when the coefficients of one variable are the same or opposites, or when it's not convenient to use graphing or substitution. For most people, elimination is the easiest method, as long as making a graph or using substitution isn't a very good method. All right, so here's our first problem, finding a break-even point. I'm going to define a couple things here for us to solve this problem. When you're in business, expenses are your business costs. So the cost to produce something. And income is what you get for selling. So the money received for selling items. All right, some people think of income as the same as profit, but it's not. It's the actual amount of money you get for selling before you take out your costs or expenses. So to find a break-even point, we want this to happen. We want our expenses to equal our income. So basically what we want to know is how many do we have to sell to break even. From that point on, then we start making profit. All right, in this problem, we have rocking chairs that we sell. It costs $22.50 to make the chairs each, and they sell for $75 each. So some of you are thinking, well, there's about $52.50 profit there. But the carpenter spends $420 on advertising. So how many chairs must she sell to make even, to break even? Let's let n equal the number of chairs sold. And then we'll just let our expenses, and I'll just write expenses for now. Our expenses are our cost to produce, and our cost to produce here is $22.50 per chair. So we're going to take $22.50 times the number of chairs, plus $420 that we spent on advertising. And our income is $75 per chair. So we can just multiply 75 times the number of chairs we sell, and that's our income. Now to break even, we want our expenses to equal our income. So that means, and I'll just use E for expenses, is going to equal I for income, and I can just substitute for expenses this equation, 22.5n equals 420. And I can substitute for I, our income, which is 75N. I'm going to subtract 22.5N from both sides, and I get 420 equals 52.5N. And actually, if you look close, that's the amount of money you make per chair selling. And we just really need to make up our advertising cost. So we're going to divide both sides by 52.5. And we will see that we get 8. So the number of chairs is 8. So if we sell 8 chairs, we break even. If we sell less than that, we lose money. If we sell more than that, we make money. All right. Go ahead and do the next problem. See if you can do it on your own. Check back for the answers. All right. Another type of problem, solving a mixture problem. A scientist has a container of 2% acid solution and a container of 5% acid solution. How many fluid ounces of each concentration should be combined to make 25 fluid ounces of a 3.2% acid solution? Okay. So what we're doing is we're mixing two things together. So let's define some variables. Let's let x equal our 2% solution, and let y equal our 5% solution. And in the end, we want to combine to make 25 ounces. So that's an equation right there. Our 2% solution plus our 5% solution equals 25 ounces total. That's one equation. Okay. Now, the harder equation is the percent equations, but if we have a 2% acid solution, that means that 2% of the total solution, which I can write as 0.2% of x, and plus 5% of the amount of 5% solution, that has to equal, in the end, when we mix them together, 0.032, which is 3.2% of our total mixture, which is 25 ounces. So, and notice I changed the 2% is 2 divided by 100, or 0.02, so multiplying by 0.02 gives us 2%, and likewise multiplying by 0.05 gives us 5%. All right, this one should be pretty convenient to use substitution. We can just solve this equation for either x or y. It's not too hard. In fact, let's say that y is equal to 25 minus x. Then I'm going to substitute 25 minus x for y here and solve it. So I get 0.02x plus 0.05 times 25 minus x is equal to, and if I multiply this out, I get 0.8 tenths. All right, using the distributive property and simplifying, we get 1.25 minus 0.5x, 0.8, 0.2 minus 0.05 is 0.03x plus 1.25 equals 0.8. Subtract 1.25 from both sides, and I get 0.03. oops, that's a negative 0.03 there. Negative 0.03 x equals negative 0.45. Divide both sides by negative 0.03 and I get x equals 15. So that means I need 15 ounces of the 2% solution. And then the other part of the 25 ounces or 10 ounces is the 5% solution. All right, go ahead and try one of those on your own. Oh, here it gives you the steps. You just have to fill in the reasons. You can pause and try and fill in the reasons and then check back with your answers. All right, so the first step they did is they solved one of the equations for y. Then they substituted that value in for x, for y right there, t minus x, so that they have an equation with just x in it. Use the distributive property to simplify that. And they also simplified this. Then they simplified some more, combining like terms to get this equation. Then they divided both sides by 0.8 to get x is 11.25, and then they substitute 11.25 for x to create an equation that they could use to solve for y. So, and solving for y, we get y is equal to 3.75. And so in the end, we need 11.25 liters of 20% solution and 3.75 liters of 12% solution. Okay, one last type of problem we're going to do here is a problem where we have somebody who is paddling in a river, and of course a river has a current, and when you're paddling with the current, you're going to make much better time than when paddling against it. Okay, so we're going to let R in this case be the river current speed. And we're going to let, let's let K be the kayaker speed. So there was no current at all. And now if we add R plus K, that's going to be equivalent to the speed with the river current, because we're adding them together, and that's 5.75. And if we do, let me switch that around so that makes more sense. So K, kayaker plus river current speed equals 5.79. Kayaker minus river speed is equal to 3.25. And now if you look at these two equations, you'll notice that we have R here and minus R here. So the best method here would be just to add them together. So then we get 2K. R plus minus R is 0R. And 5.75 plus 3.25 is 9. Then we can just divide both sides by 2, and we get K equals 4.5. So that's the speed of the kayak here. It says, what is the speed of the river current? Well, we can just substitute that in. The kayaker plus the river was 5.75. And so that means 4.5 plus R is 5.75. And subtract 4.5 from both sides, and we get R equals 1.25. So the speed of the river is 1.25 miles per hour. All right, go ahead and try the next problem. Okay, one equation is already solved for one of the variables. Then you want to use substitution. Visual display is needed. Then you want graphing. Coefficients of one variable able to be made the same or opposite. Then you want elimination. So I think we would use elimination to solve this. And the reason is because none of the other methods are really appropriate.